All right. Thank you, folks, for attending. My name is Sachin Lakhanpal, and this is my colleague, Abhidnya Joshi. We both represent Veritas Technologies. Veritas Technologies is a storage management company and a data protection company. We've been doing software-defined storage for the last 20-plus years. Some of you here might have used our products in the past. We've been protecting data from bare metal, physical servers to virtual machines, and now onto OpenStack. We are showcasing two products at the summit. We have a booth, and I'll refer how to get to our booth. Today, the topic is going to be how to, we're going to showcase a solution which we are implementing on our storage platform that provides a highly available DR-ready, OpenStack-based private cloud. This was a 3 data center environment, and we're showcasing how the storage platform can be leveraged to make OpenStack ready for enterprise workloads across data centers. So what are the problems? I mean, what are the gaps which we need to fill in the OpenStack ecosystem as enterprises are adopting OpenStack, right? The traditional enterprises have a DR strategy which stretches across data centers, across geos. There's a high availability requirements for data, very strict SLAs around RPO, RTO. The existing solutions that have been around for a while can get complicated, especially SAN solutions, hardware-based solutions, where you have to put a lot of infrastructure in place to get to a DR solution. And at the end of the day, the storage management for this kind of environment is very complex. What does this all lead to? As enterprises adopt open source, open everything, they're looking to keep a tab on cost. We don't want to spend a whole lot of money implementing an expensive DR solution. Storage becomes inefficient if you are not keeping track of how the storage is being used across sites. And needless to say, your OpEx and CapEx go out of whack. The solution that we are proposing is a geo-distributed data center deployment, mostly built out of DAS, commodity disks, commodity storage, and implementing availability and DR solution inside the software itself, giving a choice of replication modes, making the data available at different sites and different, for meeting RPOs, and providing a policy way to manage, the entire end-to-end solution. That's what we're, going to talk about today. This is a live use case which Veritas storage was used for. This is a multi-tenant environment. A customer here was looking to deploy a 3 data center for content distribution. Very highly, used content distribution platforms. I cannot take names here, so I will just talk about technology. The 2 data centers, again, all of this was serving OpenStack VMs. 2 data centers were at campus cluster distance, about 5 to 7 kilometers, and the 3rd data center was about 500 kilometers. And the RPOs that we had was to have the 2 campus cluster distance sites always in sync, and the 3rd site could catch up, although we were asked to also propose a solution for a synchronous replication across the 3 sites. As we know, OpenStack with on a single site, it's not a problem, but when you're looking at making the data available across the sites, making data available is one part. OpenStack orchestration is another solution, which I'm sure we are looking at it. There are other companies also looking at it, and we hope we'll have a solution for an end-to-end OpenStack DR fairly soon. Today we're going to talk about the storage portion of the solution. So what were the high-level requirements? The customer really said we wanted a low-cost commodity DAS. They wanted to be able to also use their existing heterogeneous SAN in the environment. They wanted an ability to migrate data or tier data into the cloud. And in terms of resiliency, all the 3 sites were expected to be active, active, active. Now, what that means is each site is serving its own workload, but they're also acting as a DR for the other site. So that's what we went after, and then there were strict I/O performance requirements as well. So it's a little bit of an eye chart, but kind of goes to show that this is a real solution that got implemented. It's not in production, but something which we did a very, very long POC with. The solution that we have, the storage platform solution that we used for this was exposing storage as Cinder and Manila plugins from the backend. It's a stretched file system that goes across campus cluster distance over DAS, over commodity hardware. It's not SAN, so we make DAS disks as SAN and be available across sites. The two sites are synchronously replicating to each other, and the third site catches up through asynchronous replication. So this uses the Veritas file system, and it has blocks underneath through Volume Manager. We have our own clustering solution, which provides the highly available backend to OpenStack. At this point, I'm going to hand over to cover the critical components that are required to support this kind of a DR solution. What are the missing pieces that we have to fill in as a solution? I'm going to let Abhidnya cover it.
So thanks, Sachin. So as Sachin mentioned, he just showed us the use case which we went through. So I'm going to take you to the key features which are useful to achieve this use case. So first is we support the commodity hardware. So by commodity hardware, we support SAN, DAS both. DAS is used as a shared storage by making use of our clustered file system as well as our clustered volume manager. So this is how we provide support for commodity hardware. This is very cost effective in case of OpenStack deployments. Next feature is the policy based data movement or policy-based storage tiering. We provide policy-aware Manila driver. So with this, basically, policy data is passed over to the share underneath, and whatever data gets created over the Manila share can be sent back to S3-based cloud. The main advantage of this is the cloud, S3-based cloud storage can be used as your backup store or can be just used as a cold storage. So this is we can achieve using the policy. The next key feature we support is the replication at different level. So the first level we support is at a block level. We support synchronous and asynchronous replication both. So as Sachin mentioned, it is about it is a campus cluster kind of feature where the two sites are 5 to 7 kilometer distance apart. Where they can go for a synchronous replication and for a larger distance, asynchronous replication can be opted for. This all depends on customer use case. So there are variety of features which we support in this replication. Next is a file level replication. So earlier was volume level or block level. This is at a file level replication. So here we provide the rich set of features. So we provide the replication with pattern matching. Then we have we can define a consistency group where multiple file systems can be replicated at the same time, and the consistency of all the file systems can be maintained. This is very important in case of DR specifically. Next is we provide features like snapshot and file snap, which are basically useful for local backup as well as for offline activities, or if you want to take the earlier version, work on the previous versions of your files. So these are the key features which we support, which actually take part in DR, data resiliency and availability. From here, I'll hand over to Sachin.
Thanks, Abhinav. So all of this is achieved all in the software. There is no hardware component associated with this. It's our file system. It's our volume manager. The commodity solution is basically making the clusters talk to each other and treat storage as if it's for SAN storage, but not really. And the communication between the nodes in the cluster that back up or provide the storage back into OpenStack is over 10 gig or InfiniBand. So that makes the data transfer over the interconnects between the cluster nodes that much faster. That's how we make the data available across the nodes. And I mentioned about policy management. It's very important to, whenever we're looking at providing a solution in OpenStack, we want to make sure that from a end-to-end as a service type of solutions, we allow policy-driven operations. So as an example, policy is basically action which a user can take based on definition of rules. Sample policies could be files that have not been touched in the last 6 months, either move them into an S3 cheaper tier, or if your files need to be DR'd into a different site based on an RPO, RTO, you define a policy like that and set that at the time of share creation, Manila share creation, that gets passed along to the storage backend, and we do the magic on the backend, right? We have upstreamed our code in terms of Cinder and Manila. We have implemented some of the APIs that can be leveraged for this. In the use case that we implemented, we actually used many of the APIs. Now coming back to how this all fits together, as I mentioned, Veritas is in software-defined storage. This is a software-defined NAS solution for unstructured data. It can be installed on any x86 hardware, going with how OpenStack is distributed. We want to make sure it's as open as possible. It can use any existing storage or your dash storage. A lot of focus on making the operations very simplistic and integrated with OpenStack. It can use your storage, or it can bleed into cloud seamlessly. That's really what the focus is. With that, I'm pretty much at the end of my presentation. We did 2 sessions yesterday. We did 1 session today. We have 2 products that we are showcasing. One purpose-built for OpenStack, which is Hyperscale, which provides high-performance application support based on DAS. And then the second product, which I just introduced, is Veritas Access. We have a booth in the marketplace. You're welcome to please join us there. We also are running a raffle, which will draw for tomorrow for a GoPro. But hopefully you will want to learn more about us as well. So with that, thank you. If you have any questions, we'll be here on the right side to answer.